Okay, so welcome to the fourth Minnesota NLP seminar this fall. And today we invite great speaker Shirley Hayati. And Shirley and I have been working together for a while. And like, as you know, like as everybody know, like here, like she's brilliant, kind, and so creative. And in one of her recent project with me, like she brought up this new fancy idea of analyzing lexicons in texture styles, while many other people are still only working on the sentence level labels. So I guess she will be talking about this fantastic work in her talk today. And Shirley Anugrah Hayati is a PhD student in human-centered computing at the School of Interactive Computing, Georgia Institute of Technology. She received her MS in Language Technologies from Carnegie Mellon University and BS in Computer Science from University Indonesia. Her research interests include human-centered NLP and computational social science. She has been a reviewer for multiple ACR conferences, actively promotes diversity in computer science by participating in Computer Women at School of Computer Science, Grace Hopper Celebration, Widening NLP, and currently serves as a Diversity and Inclusion Chair for NACO 2022. Her current work focuses on multi-style analysis and NLP for social goods. Okay, Shirley, go ahead.
Yeah, thank you, Dongyo, for the kind introduction. Yeah, hi everyone. My name is Shirley, and I'm very honored to give a talk about my work on understanding styles in NLP here at the University of Minnesota NLP seminar. Yeah, so a little background about me. I'm a PhD student at the School of Interactive Computing at Georgia Institute of Technology, working with the young on social NLP problems. So broadly, my research interests include human-centered NLP and computational social science. And specifically, I'm interested in problems related to social and linguistics behavior through NLP models, such as stylistic analysis, NLP for social goods, and explainable NLP. And the topic of today's presentation combines both stylistic studies and explainable NLP. Yeah, first, why are we interested in understanding linguistic styles? Styles are inherent in this text. People use various linguistic styles, such as politeness or formality, to express their communicative goal and personal attitude. And different contexts may need us to use different styles. For example, the way we talk to a friend may be different from the way we talk to a professor. Furthermore, the perception of styles from one person could be different from others. Then, how are linguistic styles related to NLP? With the emergence of virtual assistants and chatbots such as Amazon Alexa or Apple Siri, it becomes important to have such systems to be more human-like, to be engaging. So this includes incorporating styles in such NLP systems. And there are NLP tasks related to styles. For example, style classification, stylistic text generations, and style transfer. With this, there is a growing effort on disentangling stylistic words from the content words. But none of these works have looked deeply on how actually these models can explain styles, which words contribute to the how model can predict the styles. Yeah, as commonly known, large pre-trained model like BERT have been known to be successfully achieving high prediction scores or good generations, but they are often treated as black box models. Like we don't know how it works. So given that styles vary across different people, our work attempts to understand style variation by comparing contrasting words identified by humans, also known as stylistic cues, and BERT in determining a style. We hope that we can find what words are considered as stylistic cues rather than content words for a better explainability and generalizability of the stylistic models to different domains. Yeah, so here is the outline for today's talk. I will first talk about my previous research project on collecting a new data set called Hummingbird. Hummingbird consists of human perceptions on the words in multiple benchmarking style data sets, and this work is published in EMNLP this year. Then I will talk about my ongoing project, StyleX, which is soon to be wrapped up. Yeah, so please don't distribute it yet outside this talk. Yeah, StyleX is basically an explainable model using Hummingbird dataset. And finally, I will give a brief sneak peek on my initial idea on reformulating styles in NLP. Yeah, so yeah, the title of this work basically summarizes the main question and our approach. Does BERT learn as humans perceive, understanding linguistic styles through lexica? This work was done when I was at the University of Pennsylvania, working with my amazing collaborators, Dong-Hyuk Kang and La Longer. Yet, the main motivation of this work is that people use various linguistic styles, such as politeness or emotions, to express their goal. And for example, if someone says the following sentence, I will understand if you decline, but would very much like you to accept. May I nominate you? We can infer that it is a very polite text, which is not offensive. Oh, yeah. And it looks quite positive and perhaps somewhat joyful. And then now the question is, how do we humans infer these styles from the text? Yeah, for instance, in the sentence, humans find that words such as understand, like, accept, may, and so on as stylistic use for labeling the text as polite. Now, how about BERT? Here we can see these blue highlighted words, that indicate important words that BERT learns for predicting politeness. And we find that BERT only agrees with human that the word accept is a polite word. This leads to a concern that lexical explanation from BERT could be unreliable, and they seem to be different from what humans perceive. And it motivates us to investigate more deeply into the lexical cues used by humans and BERT. So our goal is to answer the main question: to what extent does BERT's word importance align with human perception? Yeah, to the best of our knowledge, there is no available data set of stylistic text with human perception on the individual words. Thus, we developed Hummingbird, a new data set with human identified stylistic words based on benchmarking data sets, which are Stanford Politeness, Sentiment Tree Bank, with data set for offensiveness by Davidson, and some Eval 2018's data set for emotion classification. We standardized the styles to only have binary labels, resulting in 8 styles. Politeness with polite and impolite labels, sentiment with positive and negative labels, offensiveness with offensive and not offensive labels, and 5 emotions of anger, disgust, fear, joy, and sadness. And then to collect human perception scores, we first fine-tune BERT on the training sets of the existing data sets. And this table shows F1 scores for some of the styles. Then we predict the label for each style on every development set. For example, we run a sentiment classifier on our emotion data set. From this, we obtain the probability score from the model for predicting each style. And then to encourage that the chosen text exhibit diverse styles, we sort them based on their probability scores and compute the standard deviation of these scores across the 8 styles. Finally, we select 500 stylistically diverse texts to be annotated by crowd workers. Yeah, so this is the interface of our data collection. Each worker was asked to label the style of the text. If we look at the blue word delicious, it means that the annotator thinks of the word as a positive cue. Yeah, and also, each worker was asked to label the style of the text, and after they select the words of the text, we can collect their perceptions. And 3 crowd workers label the same pair of sentence and style, and we take majority voting for the style label. Crowd workers obtain an average inter-annotator agreement for the sentence level as 73.2 and an average percent agreement of 27.7 for word level agreement. Yeah, from this data set, we can compute human perception score, which is an average score given by the 3 annotators. Each annotator's label will contribute a score of either 1 for a word that is perceived as a positive cue, -1 for a negative cue, and otherwise 0 for no emotion. And to obtain BERT's word importance, we use the popular technique of layered integrated gradients by Sundaranjan and Mudrakarta using Captum tool. This method computes an attribution score or word importance score of a feature X, or here the feature is the word, as the path integral of the gradient of function between the baseline input and the given input. More details of this formula are explained in their original paper. Now we evaluate how similar human perception and BERT's word importance are within each style. For human BERT correlation, we compute the Pearson's R for them across all words in the vocabulary, which is the red bar, and words which appear 3 times or more in the corpus, represented by the yellow bar. Yeah, we can see that for words that appear more often, human and BERT agree more compared to the rare words. And then now let's take a look at which words BERT and humans agree and disagree on. Yeah, this table shows words selected based on the difference of the word ranks of the human perception score and those from BERT's word importance. Yeah, this is specifically for the joy emotion. When human and BERT agree, they attend to words that are clearly associated with the styles, such as excited, entertaining, or perfect. However, for words that BERT does not agree with humans, BERT often finds words that suggest contexts in which the sentiment is likely to occur, such as movies and baseball. We conjecture that these content words, which are not exactly relevant to the styles, are mostly learned due to the bias of training dataset. For example, for a sentiment dataset, they are from movie reviews, or for politeness dataset, they are coming from Wikipedia, Editor Forum, and Stack Exchange. Yeah, so this can lead to BERT's inaccurate learning. Yeah, and then our last analysis for the intrastylistic analysis is that we look at the impact of important words perceived by human and BERT in the existing benchmarking style dataset test set using a simple co-occurrence-based classification method. By ranking the words based on their human perception score and BERT's word importance score, we label a text as having the target style if at least one word in the test sentence exists in the top N word list. And here we can see that humans word list outperforms BERT for most styles by different size of N. And interestingly, for some negative styles, such as impoliteness on the blue lines or negative sentiments on the green lines, BERT's word list performs better. Yeah, we observe that words from offensive datasets, mostly swear words, are more consistently labeled as impolite and negative by human annotators. However, these words are not often seen in the original politeness and sentiment dataset. So it explains why features from BERT models, which are trained on the original large datasets, get higher F1 score here. Yeah. As we extend our analysis on multi-style correlation, we found that humans and machine give similar correlations among the styles. For instance, positive sentiment is positively correlated with politeness and joy, and negatively correlated with offensiveness and disgust. Yeah, however, the multi-style correlation strength is greater for human perceptions than for BERT's word importance. Yeah, and then the weaker correlation across styles for BERT's word importance scores is confirmed in this lower dimensional visualization of stylistic representation for each word. Each word here is represented by a vector containing word importance scores for the 8 styles in this order: politeness, sentiment, offensiveness, anger, disgust, fear, joy, and sadness. In human scores on the left, styles cluster into two extremes like politeness, positive sentiment, and joy to the left, and anger, negative sentiment, offensiveness, and impoliteness to the right, with disgust, fear, and sadness between them. But for bird, the style groups are quite mixed. Yeah, so to sum up, we showed that birds' word importances for style prediction as calculated using integrated gradients correspond only very loosely with the human perceptions and identifying the stylistic words. These differences likely result from several factors. First, word importances computed for their words tend to be noisy. Second, bird takes or context since it's a contextual pre-trained model. Also, when it decides the style of the text, it looks at the context while humans intuitively choose the most obvious stylistic words to judge the style of the text. And finally, styles are subjective matter. So as a result, human annotators may have different perception toward the style of a sentence. This work also provides a public data set as a first step for researchers to further investigate these issues. As a future work, we plan to scale up our data collection in their size and style types, perhaps including other higher level of styles such as sarcasm and humor. And in the next slides, I will be talking about StyleX project, which is also a future work from a Hummingbird dataset as we explore a possibility of informing bird to learn human perceptions for explaining stylistic sentences and developing a generalized model for stylistic sentences in other domains. Yeah, so before I continue to the next project, yeah, maybe there are questions if there, yeah. Oh, yeah.
Yeah. So first of all, thanks. This is really cool. One of the things I was wondering about when you were talking about the differences between human and bird perception of these different style words, do you think it would be possible to use some of these words you've identified where Bert kind of falsely, it seems, associates something like baseball with joy? Like, do you think you could use something like that to kind of do an adversarial sentence type thing for Bert, where you can like kind of systemically trick it into doing the wrong thing?
Yeah, I think that will be an interesting way to expand the like stylistic lexicons by using this adversarial method so that yeah so that word won't confuse this like content words with stylistic words. But I think this can be done for styles that are not strongly coupled with the content, because there are some styles that can be like really hard to disentangle the stylistic words and the content words. Yeah, but I think for like, let's say sentiments or perhaps emotions, maybe it could be done. Yeah, thanks for your question.
Yeah, thank you.
I have a question. Yeah, go ahead. I'll go after you.
If you noticed any words that were ambiguous, either inherently or with context, different contexts.
Oh, you mean like, are there any ambiguous words? It depends, like which ambiguity, like is it from the model or from the human perception? If from human perception, usually for ambiguous words, it will have like lower agreements among the annotators. So yeah, the score will be maybe like 0.333 and so on. It's if it's from the models, yes, somehow I realized that it's kind of hard to actually understand the word important scores like from the model. So yeah, sometimes it can be just like random or just noisy. So yeah, it's kind of hard to decide whether how the model thinks that this word is ambiguous or not.
Okay, thanks.
And the next question from,
I have a question.
okay.
This one is actually about data collection. It's super cool. And the last slide, you said this data will also be available, I guess, after you publish this work. I guess, what were the rules around making sure that like the humans even agree on what's polite? Was there like a minimum score? I think you said if at least 3 people agree that it's polite, then you entered it or something like that. Am I correct? So there's some kind of rules around that, right? Some kind of like majority or something.
Yeah.
Okay.
So we use majority voting to decide whether the word as stylistic use or not, which is 2 or 3 people are agreeing. Yeah.
Out of how many?
Out
There's
of 3,
someone
out of 3 annotators.
Oh, out of 3 annotations. Just because sometimes people can perceive as something as offensive because they're having a bad day or something like that.
Yeah.
All
Yeah.
right. Well, thank you.
Thank you. Yeah, actually also for the future work, when we plan to scale up the data size, we are also thinking of maybe adding the numbers of annotators, like from 3 to 5. Yeah, if possible.
And they're all native English speakers and stuff.
Yeah, we limit them to be people residing in the United States. So we hope that they are like English speaking
Okay.
annotators. Oh, any other questions? Yep.
Yeah, so you're like one potential future work, which is scaling up the data size. Have you considered using some sort of eye tracking devices? I talked to this idea with Korean before, but let's say that you make annotators to see the style, the sentence, and then keep tracking like which parts are they making more, like spending more time to read it, to predict this is sentiment, this is positive or polite, and maybe you can just easily collect them. I don't know. What do you think?
Wow, that's really cool. I never worked with eye tracking device before, but I think if we can use that for collecting the data set, that will be really cool, because maybe sometimes what people see, it can be different from what they label. If there is any difference, that will be also an interesting thing to investigate. But if they are consistent, like in what they seeing and in what they're labeling, that will also be an interesting finding.
Please
So,
talk to Karen.
yeah. But I wonder though, like if we have this eye tracking tools, should we like give it to the annotators, or maybe we cannot hire crowd workers in doing that? I haven't tried it.
Yeah, I have to look into this a little more. I haven't done eye tracking in a while, and I think now they're like this pie gaze framework that I think can work with webcams. So I'm not sure how good it is, but yeah, that's definitely a concern, is like scalability with the data collection.
And also, I think if we do eye tracking, it means that we need to record them. So yeah, I don't know how much crowd workers will agree in exposing their face into the camera. So
yeah, well, one thing that could be interesting too is just to even use the same sentences that you've already collected like people's opinions on, and just see if the eye tracking like matches really well with what people already say, then we don't really need to do anything else. So
yeah, right. That can be like pilot study before like scaling up this data set using the eye tracking method. Yeah, that's really a cool suggestion. Yeah. Perhaps any other questions or comment?
I have like a comment. I think it's interesting that humans were obviously in one camp or the other camp, or in that graph you had very obviously.
I have a quick question.
Wait,
let me just finish, sorry.
Yeah.
There had like regions that were very clearly identified, but with the machine it was all confused, it was all less defined. Just would almost feel like humans are indecisive and machine would be kind of making a decision, but okay, that's it.
Yeah, I think for example, in this table, yeah, like having the movies and baseball or documentary, those can be like very like related to how people experience joy, so that the machines can think that these words are related to the emotions. But actually, if we apply this to other domains, yeah, humans know, I think humans know better that these are not emotional words. Yeah. Oh, and who was going to give another comment? I think someone was like saying also at the same time. Or any other comments, or maybe
during the annotation process, like we're um am I audible right now?
okay, I can hear you.
Oh, sorry. So I was just wondering if like during the annotation process where people were never like weren't able to find like a decisive keywords in this text. So like were people able to always find like a specific word that signals this style? I was just curious about that.
Oh, yeah, that's a really good question. So if we go back to this screenshot, if the person chooses neutral for the label of the text, we allow them not to select any words in the text. But if they choose positive or negative, we require them to click words. Yeah, at least one word in the text. If they don't click any words, we will not allow them to submit the answer.
Okay. Right. I see. So there's an assumption that like there is always a word that signals this like specific style, I guess. That's kind of like assumed.
Yeah, that's like assumed, but we already did like before we released this task, we were already looking at other styles as well, like say like formality, and we find that it's kind of hard to find like specific words in a text to make it formal, and maybe it's easier to find informal words rather than formal words. So when we decide these 8 linguistic styles, we already discussed that, yeah, words can identify these styles. Also, this is supported by previous works on, let's say, sentiment lexicon dictionary or emotion lexicon dictionary, offensive word dictionary, that yeah, these styles are strongly related with the words there.
Okay. Yeah. Okay. Okay. Thanks.
Any other questions or comments? Okay, then I think I will move on to the next project. Yeah, so yeah, this project is about a StyleX, a model for explaining styles by leveraging human perceptions on lexica. This work was done with my 4 collaborators, and we are now in different universities. Yeah, so this is an overview of the whole StyleX model, which I will explain in details in the later slides. So if we can see on the left side, we have a part for collecting perception scores for unlabeled tokens in the existing benchmarking style dataset. So these big style datasets are different from Hummingbird. Yeah, we need to do this because Hummingbird dataset size is quite small. Hummingbird only contains like 500 sentences, while other benchmarking style datasets have at least more than 5,000 training instances. And then on the right side, we have a model which uses both Hummingbird's ground truth and of human perception scores and the pseudo labels of the predicted perception scores on these other huge original style datasets. And then yeah, these original data sets that we use here are the same as the data sets that we use on the Hummingbird project. Yeah, now let's take a look at the detail of perception labeling of the tokens. yeah, for the data processing, we only use, for this part, we only use Hummingbird as the training set, and this is the data processing. Yeah, we can see on the left table, these are examples of sentences with words with the ground truths of human perception scores, and we convert these scores into binary labels of 0 and 1, where 1 is for words where majority agrees, is shown in the on the right table. We can see that now the score for the word sunny changes from 0.67 to 1, and then for the word sad, it changes from negative 0.67 to -1, and then the perception score for the word day becomes 0. And yeah, these pairs of sentences and the binary labels of the perception scores of the tokens become the input for training the pseudo labeling perception model. And we use binary cross entropy loss for this. So the pseudo labeling model can predict pseudo labels for sentences that don't have perception scores. And then, yeah, this part is for the sentence labeling. Yeah, so the idea is that we have now the existing style data set, and Hummingbird, that becomes like an input for to fine-tune the BERT model. And then for the existing style data set that don't have the perception scores, we use the pseudo labeling to predict the pseudo labels, and we use both these like predicted perception scores and also the ground truth perception scores from Hummingbird to later predict the sentences style. Yeah, so here, yeah, it's similar to the previous slide, but I break down this into like step by step. If we start from the left, we have the sentence and the perception scores as an input to the BERT model. And then we take the last hidden state of this BERT model to become an input of the pseudo labeling model. And then we get the perception logics. And then we combine these perception logics and the sentence, and then get the, so the size will be 768 plus, yes, either 1 or 2. 1 is for styles like emotions, because it only have like one positive style, like either anger or not anger, like joy or not joy. But for politeness and sentiments, it can be like positive and negative, or polite, impolite. And yeah, we have like 2 logics, and then we take the max pool of this as an input to the style classifier, and then we predict the sentence style. For the experiment settings, we have 2 things to evaluate. One is the model performance for generalizability, and then the second one is for testing the explainability of style X. And then, yeah, for the model performance, we have these test data sets coming from the original benchmarking data sets, which are the same as we use in the Hummingbird. Oh, okay. Oh, yeah, do you have any questions?
So could you go back to the model slides? Yeah,
Okay.
this one. So what's the difference between your model and just a typical BERT sentence classifier? So are you using the Hummingbird's lexicon annotations as a sort of supervision, making the model to predict this sort of like perception scores for individual words, and then based on them, you make the final sentence classification?
So we have 2 steps. First, when we use Hummingbird only dataset as the training, it's here. Yeah, the token perception labeling. So it's on the left part, the one with the colors, not the gray parts. And yeah, we get a pair of like text and perception scores, and then from this we train like a pseudo labeling model.
So what is perception score here? It's similar to what human annotated, right?
Yeah, it's similar to the.
So the basically model is predicting a perception score of each individual word, like how important they are, right?
Yeah.
I see. And then using them,
using them we get, we get now the existing style data set which don't have perception scores for the words in the sentences. We now have the predicted perception scores, or we call pseudo labels.
I see. So basically your assumption is that if the BERT model knows that which words are important, then it may have a better prediction, or that's your assumption, right?
Yeah.
Okay, gotcha.
Yeah. If BERT, if the BERT can see like which words are important following like humans' perception, then my assumption is that it will lead either better prediction or similar, or at least generalized to other domains.
Okay.
Yeah.
Thanks.
And yeah, so you're going back to where we were. So for the test data sets, we have two categories. The original data sets are the same as where we trained the model. Yeah, but of course we use the test part, the testing part. Yeah, this is also the same as what we use in Hummingbird project. So for politeness style, it is from like Wikipedia edit forum and Stack Exchange. For sentiment, it comes from movie reviews, and for offensiveness and the 5 emotions, they are coming from tweets. And then we also have out of domain data sets to test the generalizability of our approach. Politeness data set for the OOD data set coming from emails. And then for sentiment, it comes from Amazon reviews on different products, and we exclude movie reviews on these Amazon reviews. And then for offensiveness, there's a same eval task like called offense eval. Yeah, they are also tweets, but since they are coming from different data sets, so we are hoping that maybe it could be quite different. And then for the 5 emotions, we use the Go emotion dataset, which are coming from Reddit posts. And then this is the results for the F1 scores for several styles. The baseline is only a fine-tuned BERT with original dataset and Hummingbird training sets. And then we can see that for the original dataset, most of the styles have better F1 score when we trained using StyleX, except for politeness. Yeah, I can see that even though this improvement is quite marginal, but at least they are like comparable, which means that StyleX approach doesn't hurt the model's performance. Yeah, and when I look deeper into the politeness dataset, I can see that it's debatable. Yeah, this is also have been something that we discussed internally. Yeah. And then for the out of domain data sets, we can see that StyleX is always better than the baseline. And then, let's look at deeper into whether the words help. So this is where it changes, where StyleX prediction corrects what the baseline predicts. So the sentiment label should be positive, and we can see that here the words "thanks very much" is labeled as positive using StyleX, with the bird emoji, and then the robot emoji is from Captom used on the baseline model. We can see "thanks" and "very" are identified as red, or which is negative. And then this is another example where the label of the sentence is corrected by StyleX. We can see that here, yes, there are still hashtags because those are tokenized by BERT, but we can see that the word mediocre and funny are identified as negative by StyleX, but in Captom, they fail to find these words as negative. So as we continue on evaluating the explainability, we compare like StyleX versus Captom. We have two aspects to be tested. One is sufficiency test, which means is our explanation faithful or sufficient for predicting the style of the sentence. When we say explanation, it means the words, like the important words that we got from the model. And then for human evaluation, we ask, do humans understand StyleX explanation better compared to the baseline? So this is the setup for the sufficiency test. For both StyleX and Captom, we select top 30% words with the highest importance scores from the training sentence. And then, so for example, if the sentence length is like 10 words, we select like 3 words from that. And we only use these 3 words, like most important 3 words, as an input to fine-tune BERT. And then we will evaluate the model performance based on the F1 score. Yeah, so this is the result from like CAPTOM versus StyleX. We can see that StyleX F1 score is always higher than CAPTOM. And on the right column, we see the baseline when we use the full sentence as the training input. And yeah, we can see that StyleX F1 score using only these like top 30% words are quite comparable with the baseline. And even interestingly, for fear, it's higher than the baseline. Yeah, and then we also test whether these important words found by StyleX and CAPTOM also match the existing stylistic lexicon dictionary, like sentiment lexicon or emotion lexicon. Since we cannot find politeness dictionary, we use only like positive and negative, like sentiment dictionary, and then offensive dictionary and emotion dictionary to test this. So we have 2 sets of evaluation. On the left, like 2 left columns, we compare like the average of important tokens that appear in the dictionary. So these important tokens are from the okay, let me rephrase this. So we have like, let's say top 3 words in the sentence, and then we see among these top 3 words whether they appear in the lexicon dictionary. If they appear, and then we divide this with the average slang, which is, yeah, let's say 10. And we got that for StyleX, it's always higher than CAPTOM. And then for binary overlap, we only measure whether among these 3 words they exist or not. So it's just like counting like +1. And then we can see for offensiveness, it's really high because we think, yeah, offensive words are easier to, like offensive words in the dictionaries often also appear in the like maybe tweets, but for other styles like sentiments or emotions, they are quite low, like ranging around 30% in the binary overlap measures. It's because when I look at the existing lexicon dictionary, they often use like big words that maybe people don't use in daily conversations or like social media text. And then, yeah, so this is the result from human evaluation. So the setting is also similar to the sufficiency test. We select like top 30% important words to be shown to the human annotators. We use crowd workers to do this. And yeah, why we do this? Because we realized that the highlights in StyleX, the number of highlights in StyleX is usually lower than the number of highlights from CAPTOM. So we don't want some bias from the annotators to select only explanations with more numbers of highlights. So we try to make them in the same number of highlights for the sentences. And we can see that for these styles, oh yeah, so we have 3 annotators to label. So we show like these explanations. So the settings is similar to this. Yeah, but we randomize the order, and then we ask them to select like which explanation is better. And then we have 10 samples from the original data set and 10 samples from the OOD data sets. So in total, one annotator will annotate 20 sentences. And then we take the majority agreement from these 3 annotators working on the same pairs of 20 sentences. And we can see that StyleX always wins. Yeah. So yeah, the takeaways is that first, StyleX provides explanations, which is considered better by humans, and it doesn't hurt the performance. And then StyleX explanations are sufficient for model prediction and more preferred by humans, and StyleX is more generalized than the baseline, or when we test on the out of domain data sets. The next slides will be very brief sneak peek on the next work or ongoing work actually that I'm thinking to do is like how can we reformulate styles in NLP. So first we look that context and author's personal identity contributes to a style, and then how audience perceive the style also matters for the style, and the style and the content can mix a text. And there are also like features related to the styles. Yeah, this is like it's still ongoing, but yeah, I'll just like put it here. And yeah, that's all. Yeah, thank you. And yeah, I will take any questions. Oh yeah, also the Hummingbird data sets are already out, so you can take a look at this link if you want to use our data set. There are also like codes related to this project, so also in this GitHub link. Yeah.
By the way, sorry to interrupt. So this Shirley doesn't have any like extra time today. So there won't be any student discussion today. So maybe this 10 minutes, 13 minutes might be the only chance you can talk to Shirley, or you can also share the emails, of course. Yeah.
Yeah, I will have a lab meeting right after this talk. So yeah. Yeah, so any questions or comments about Stylex or Hummingbird or styles in general?
Shirley, I wonder if you could go back to your last slide where you talk about kind of, yeah, exactly.
Okay.
I think I remember from one of your previous presentations where you talked a little bit about some future vision for using what you've learned from Hummingbird and other things to sort of help with things like separating style and content and that sort of thing. So I wonder if you could speak about that a little bit.
Yeah, so yeah, that is related to this project actually. So I'm thinking of like some styles are like strongly coupled with the content, so it's hard like to split them out. But some styles, like it may be like easier to like separate the stylistic words and the content words. I think in my previous slides I have like this like arrow and the list of styles, like which one is more strongly coupled, which one is loosely coupled with the content. Yeah, but I think for now I need to think deeper on that diagram, maybe thinking of whether taking like current data sets to support that idea. Yeah, that's still an ongoing project. Yeah, thanks for your question. Yeah, any other questions?
Yeah, so given this overview of your style reformulation design, have you also thought about interpersonal context? So if you talk to maybe your advisor,
Mhm.
how does that affect to your generation? Or not, I mean, the politeness and formality are some examples of those, but have you seen any work that systematically control the interpersonal context and then somehow integrate them into the generation system or classification system and so on?
Yeah, I think for now I'm not aware of such works yet, or if there is any, I think it will require like much resources to build such data set, because we will need, besides the style itself, we will need the interpersonal information, right? So if we only collect that, maybe from crowd workers, we need to ask like their demographic information and so on. Or if we want to collect from existing platform like tweets or Reddits, we need to know about the user information too, which may not be like publicly available. Yeah, and I also attended like a lab visit from Kaisa Lab from a university in Germany by Lucy Fleck. Yeah, I found something really interesting related to the work of sarcasm, where they said that sarcasm depends on the context and also perception of the user. So some words can be like, no, sorry, not words, some sarcastic sentences can be considered as non-sarcastic given the, let's say if the situation is like that.
Mhm.
Yeah, I think that's really interesting.
Yeah, that's very interesting. So maybe like emotions or sentiments, maybe those are speaker's perspective, in my opinion. So
Yeah.
what I'm saying is basically, oh, happy text
Mhm.
or positive opinion of myself, right? But maybe
Yeah.
humorous or sarcasm, I'm trying to make you happy or feel bad or laughing or something like that. So have you thought about like this speaker and listener relationship with respect to each style and how they're coupled
Yeah.
and affecting each other?
Yeah, I think that will be really interesting. Yeah, when we to incorporate those factors when we want to study styles.
Okay.
Yeah. Okay. Any other questions or comments?
I also have a quick question on the set of the style that you defined. Like you have the 8 categories of the the
Yeah.
style, and I wonder how did you define that categories, and you wonder if you have also experienced that if you do not have that static number of the classes.
If I do not have what? Sorry.
Static numbers, like
Numbers. What do you mean by static number?
so not like fixed numbers of labels of styles.
Oh, yeah. For the how I choose the 8 linguistic styles, it's based on the previous work by Dongyop. Yeah, it's shown in here.
Yeah, I actually couldn't catch up like 13 minutes of this talk. So.
Yeah, it's okay. Yeah, so this is where, so actually in Dongyop's paper on Xflu, yeah, they have more styles, like more than 8 styles, including like formality or even like the demographic of the user. But here I only use these 8 styles because when we have like internal discussion between us, we find that styles are hard to find the stylistic words. Like sometimes I like higher level, like humor, for example. Can we find like humorous words in a sentence? We're not sure yet. I think we need a deeper study to decide that. So we select like these 8 styles because we think they are easier to for us to find the stylistic cues or stylistic words. And then for the emotions, actually there are more than 5 emotions, but I choose these 5 emotions based on the top F1 scores after I trained the model on getting these results for selecting the stylistically diverse text. And also I think these 5 emotions are quite popular and basic emotions too. So yeah, that's how I choose these styles. And yeah, for hate and offensive tweets, there are actually 3 labels, like offensive and hate speech, but we decide to at least simplify the problem because we already have so many styles. So yeah, we just choose offensiveness and not offensive and remove the hate speech. And the other question for the static numbers, do you mean that the styles there will be like so many styles in the classifier to predict, or can you elaborate more on that?
Oh yeah, like for your maybe future study or like plan to extend like unknown labels of the style, like not only the 8 categories.
Yeah. So yeah, we plan to scale up the data sets. Like maybe I'm thinking like adding, let's say, formality. Maybe it's hard to find the formal words, but what if we change the problem into finding informal words, which I think is easier. So yeah, so we plan to like scale up the number of styles in this study too. Yeah.
Thank you.
I guess like a related question I have to that point is how often is it a problem where maybe you have a sentence and both like impolite and offensive and disgust are all like appropriate labels for it, right?
Oh, yeah, right. Actually, that is an interesting point to investigate deeper. And our hummingbird data set, yeah, will be a good resource to look that deeper. We have like a high level study on this visualization. Where is it? Yeah, here. But yeah, if you can see, like those are the like offensiveness, disgust, anger, and like words are mostly on the right side for both human and machine. Yeah, human and bird. Yeah, if you see the colors like grayish, brown, and so on, that means that yeah, they are like overlapping. But yeah, I haven't looked deeper into these problems yet. That will be a really interesting direction.
I have a really high level random question.
Okay.
So whenever we have a certain style of language that we are interested in, let's say I'm working for a commercial or advertisements, whatever, marketing, and I'm interested in maybe empathy of language, or maybe like how subjective language is. I don't know, maybe some certain aspect of language, right? Then do we have to repeat the whole procedure again, like collecting users annotations and then make labels and then increase the number, calculate the user agreement score, and then maybe train birds? I mean, then we have to keep doing this until forever.
Actually, I'm thinking, what can we build like a basic styles so that we can reuse it for other higher level styles. So in my ideas, that styles are not flat, but it's like hierarchical. Like there are like simpler styles. I think these 8 styles that I include here are among those simple styles, and there are like higher level styles, maybe like humor, sarcasm, and so on. Maybe like empathy or other works like maybe persuasion, recommendation, and so on. Maybe they are not styles, but they are more like the way of people want to do something, like they want to recommend, they want to persuade, and then from this goal, can we use styles at the bottom of that? So if we can leverage these styles, maybe to predict the goal, or to be used for like this goal-oriented tasks like persuasion, recommendation, negotiation, and so on. Yeah, I think you don't have to like redo this whole task again, I guess, if this works.
Okay.
Yeah.
Yeah. Thanks.
Any other comments or questions?
Okay, then maybe we can finish. Yeah. Let's give a big applause to Shirley. This is amazing talk. Thank you so much.
Yeah. And thanks for the opportunity.
And please feel free to contact Shirley if you have any additional questions about her work. Okay. Okay. Thank you. Bye-bye.
Thank you. Bye-bye.